Hello, everybody. Welcome. Thank you for joining us at the Transform track at DockerCon. I actually lost my intro for Mark, but he's my fellow coworker at Docker, and I'm going to let him introduce himself. So please, let's give a round of applause to Mark Church.
There we go. Okay. All right. Well, thank you for joining, and happy DockerCon, day one. Everybody having a good time? All right. All right. So I really like these. I have to comment on these slides they gave us. This guy programming on the edge of a building. I can hardly advise it, except the scariest part is he's probably deploying to production as well. They told me I had to say a bad joke, so I did a bad joke. So what we're talking about today is a topic that is very near and dear to my heart. I'm a product manager at Docker, responsible for platform ops and networking, but in a past life, I was a solution architect in the field, and I worked with a lot of the customers that are about to come up here today. And what we noticed was a lot of the same trends and issues amongst our customers in getting Docker into production. And a lot of these trends were the same things. It was big company problems, because all of you face these kinds of things with a big company with lots of inertia and all the idiosyncrasies of large company that you have to fight against. And we saw a trend with our most successful customers around doing something where they centralize the way that they deploy containers, and they centralize their knowledge of Docker within their company. And we called this a center of excellence. And I know there's probably a better word for it. And the center of excellence was really about cutting through all the red tape, because in your company, there's so much inertia about bad IT practices. Think about all the different things that you have to fight against. And I hope I'm not giving anybody cold feet or anything like that, but fighting against developers that have SSH access and security teams that don't understand containers and instead just think of everything as in the terms of VMs, in the context of VMs. And all these kinds of problems are the kinds of issues that we face against. And so we want to talk about the different strategies that are used from an organizational perspective. And I'm sorry this isn't really a talk where we have a demo or anything like, or a CLI involved, but we noticed that the companies that don't pay attention to this strategy, that don't take a look at how it's done from an organizational perspective, are the ones that take the longest to actually get into production. And not only does it take longer to get into production, we actually don't even need this. Not only does it take longer to get into production, they do it with more toil, and it takes more time, and it's more difficult for it to do. And so I'd like to go ahead and introduce, let's bring our panelists on stage. So some of these guys we've worked with for a number of years, and some of them 2 or 3 years with hundreds and thousands of containers. And so we have Tim from MetLife, Megdut from PayPal, Matt from Hertz, and Mike from Splunk. So why don't we go ahead and get started, and we'll go down the line from here and just introduce yourself, your role, and kind of what the state of Docker and containers is in your company.
Thanks, Mark. Happy to be here and talk to everybody. I'm Tim Tyler. As Mark noted, I'm a Docker captain and a principal solutions engineer at MetLife. I've been involved with MetLife's journey down the container road since we started, which was approximately mid-2016. We deployed to production very rapidly in 2016, and we're currently running Docker clusters all over the world, servicing sales and servicing applications for our customers.
Thanks, Tim. My name is Megdut. I am a Docker evangelist at PayPal and managing the entire kind of Docker transformation journey or containerization journey at PayPal. If you look at our numbers, last quarter, PayPal did around like $130 billion in transaction volume processing, $3.69 billion in net revenue, 237 million users all across the world. And thick in the center of it, Docker is running and powering that. So we have been in production for over the last 2 years, and almost 200,000 containers running there. So it is right. If Docker goes down, if our containers go down, it will be a direct impact to our business. So that's how we put it.
Matt Slavin with Hertz, Cloud Director of Operations. 100-year-old company getting into containers, moving from AS400s to new technology, new trends, and going to cloud. What a decade, right? So yeah.
Hello, everybody. My name is Mike Dickey. I'm a senior director at Splunk, and I'm also the area owner for our engineering infrastructure team. We have about 100 engineers that manage all the internal systems, tools, frameworks, platform, CI/CD, build systems, etc. Today, most of our engineers, I would say all of our engineers, but we've been acquiring a lot of companies lately, so I can't confidently say that. But most of our engineers use on a day-to-day basis our tooling and Docker in order to test the software that they're developing.
Thanks, Mike. So the funny thing is that two of you were actually my customers in the past, and so now the tables have turned and I'm asking the tough questions. So first question, this is a softball thing, just do you agree with the premise? So kind of moving down the line, what's the value of having a centralized container team that's ultimately responsible for your Docker or your container strategy?
So for MetLife, we've had essentially two container teams. One started out as an innovation team. It was a matrix team that we brought together to solve a very specific problem. And by the time we solved that problem, we realized that we needed to form a tactical team that was focused just on setting the policies and procedures for our containerization efforts at MetLife, and then teaching all of the functional teams in our engineering and operations organizations essentially how to fish. So we've got a central group that's making sure everything's done correctly, but then we're teaching our peers in our other functional teams how to actually get the job done.
So in our case, if you look at PayPal, we have a payment operating system. That's what you say on top of our infrastructure. And then we are building experiences for our customers. If you look at the developers, they are looking at the best of the front-end technologies or the payment technologies. They don't have the time to learn the best practices of Docker, writing the best Docker file or compose files or what to do. Even our infrastructure operations engineers as well. So our central team was formed of skill sets varying from kernel imaging to all the way to application frameworks. And we did most of the hard work in implementing the best practices so that the developers are not bogged down for those kind of decisions. And then slowly making power developers and then normal developers innovating. So we did kind of phase journey on that one. So that's the motivation of the central team.
That's interesting. So I guess one follow-up question on that is what do you think the responsibility, the shared responsibility is between the lines of business applications and this central team?
Yeah, I mean, for our strategy, we thought we saw consequence of silo teams, right? So for us, it was about bringing everybody in. I mean, Wall Street's using our terms, right? They're saying agile and digital and these kinds of things. So it was important for us for everybody to get a part of the culture. So an example of that would be like the marketing team going in and executing jobs, those kinds of things. Really getting past the concept of just the IT workshop where you want to deploy a simple app, but you got to go through this whole, process of project. You move past that. Everybody wants things now. So how do we get it to them now?
Yep. Very good. One question for you, Tim, and because I thought you had an interesting response to this earlier. So for this original team that you built, what was kind of the DNA or the makeup from a skill set perspective and kind of the type of people that you wanted to lead on this team?
Yeah, so the original team was, again, it was an innovation team is what we call them. This one had a very specific name. Some people might have heard MetLife's Mod Squad. It was a cross-functional group of engineers and software developers that we brought together. So we had folks from architecture, folks from engineering, different functional areas in engineering, folks from operations, and folks from application design. We brought these guys together and asked them to put together a minimum viable product that we then took to production and operationalized later on. And the DNA of that team was really key. I like the way you put that. MetLife is very proud of how diverse it is as a company and how we embrace diversity. And I like to talk a lot about how the diversity that we brought to the team was critical, in my opinion, to the success of that team. It was a small team, with a big job to do, and not only was it very diversified in terms of gender and ethnic background, but we had a large range of ages on the team, with folks that were fresh out of college and folks that were slightly further along in their career, like me, that were, I would say, slightly older, and we brought this team together with all of these backgrounds and different perspectives, and it made the team click and it made the team work. And not only did we deliver Docker as a platform for our first production application, we also had other cool things pop out that nobody even thought about, like chat ops, for instance, because people were thinking out of the box and thinking in different ways, and it was diversity that made that happen.
Mm-hmm. So I will add some points. So I would say it's all about the team. If you have the right team, you're going to get it done. Otherwise not. So for us, if we had thought about the best container experts, hire them or train them and tackle a 20-year worth of enterprise company with so many gory details you don't want to know, the most common answer will be, let's do a new use case, right? So the way we formed our team was get the experts, whether they were like system experts or application framework experts, know all the details ins and out, and then match them with like container experts in the team. So that was the perfect union where we could actually think of going in production and know all the pitfalls like way ahead of time. The other thing pretty much was, this was a new thing. We were asking and making a lot of changes everywhere. We had to do all those changes in other people's code bases. And the respect and old timers being there in the team helped a lot in having easy conversations around those changes. So it was a very tactically important to have that kind of team composition.
Yeah, so one trend we see a lot actually is, there's the balance between risk mitigation and then innovation, right? And it's particularly on teams that are very familiar with the technology they already use and maybe they don't understand Docker so well, there's a big trade-off between the risk mitigation and innovation. And many managers are gold on uptime and them not bringing risk into the organization. So question for you, Mike, exactly how do you balance this, and what kind of use cases did you see that kind of helped you de-risk bringing Docker into the company?
So at Splunk, our initial use case for leveraging Docker technology was to help improve our testing process. And because with testing, typically developers will bring up an instance, they'll run their tests, and they'll tear it down. The risk if something goes wrong in that process is relatively low, because if you can easily recreate the environment, rerun the test. So we really drove that adoption and built out that knowledge base and the understanding of how to use the tools and the technologies by driving it through test.
Now, I've seen customers do anything from, say, we're going to take our most difficult application and containerize it, and then if that works, then everything works, or take their easiest because they could do it faster. Anybody else have an opinion about, which either extreme is better or something in the middle? You can't just say it's all about balance. It's too easy. So, but if there's any specific opinions on that?
Yeah, I think as IT people, right, we become focused in what we see as the problem, right? We don't necessarily have the visibility to the business, and like you'll have a 10-year-old printer that prevents you from printing payroll checks efficiently every time, and it creates a bunch of tickets, or you have loss to revenue, right? So which would you see as a bigger opportunity, company growth or fixing old problems? And I think that's the challenge that we have to ask ourselves as we move into this container technology is, how does the business view us? What does the business see as a problem? And then we meet that need. That allows us to play more and to do more in a shorter amount of time.
So to add, our sequence was initially take the apps, which nobody cares. If they die, that's fine. But quickly we moved on to apps, which was kind of the champions. You have to find champions in the big company who really wants to partner with you and be patient with you and not going to scream on every failure. And so we took those apps in the second wave. But we did take production impacting apps very early in that cycle, because we didn't want to tackle the hardest apps at the end. Not only it gives a good learning process, the credibility factor is there, that if you can solve the problem for the most important set of apps, then maybe we can fund this for all the apps. So we didn't take them at the last in that sense.
I agree with that. That was, we started hard, in my opinion. We picked a microservices application which was something we had never done before. We layered in a whole lot of new technology, most of it open source, which we had never done before, or at least hadn't done a lot of, on a brand new platform, which we had never used before. And from an application point of view, I think we took the hard road, but we delivered, and because of that, it made a huge impact. If I were to back up and do it again, I don't know if I would choose the same path, but the impact that we made at the end of that first part of our journey was so huge that it made the rest of the journey much easier.
Yeah, for an insurance company, you guys really live on the edge. But I think it's a good tale to tell, because we've seen other companies also fail at the same thing at trying to take their hardest app. So in some ways, I see the strategy that is kind of works is take your most difficult app, dial it back to see which apps provide the business a lot of ROI, but aren't the most complex thing you have. So you have a use case that builds some credibility without necessarily incurring too much risk. So anything else? So not just from a risk perspective, any other criteria that you were looking for in your early applications that you were containerizing?
I would say probably a lot of web applications were a lot of customer-facing apps. So that's the question of duality, right? Does the front end come before the back end, right? So for us, it was about sizing up workloads, and it was about the amount of payoff. And I think that's key. For us, it was chatbots, Lex, and those kinds of things. Not only did it empower the business to where they could do these DevOps functions on their own without needing IT support, but that completely changed the way that the business looked at us, right? Which was this old monolithic approach, right? So I think when you size them up, right, look at risk versus reward, and look at how you can make it a little bit better for that team or that business at the end of the day. I think that's where you start to get into the DevOps methodology.
Yep, absolutely. So there is a lot of patterns and anti-patterns when it comes to cloud native and everything we talk about when it comes to containers. Our apps are not pretty, right? There's a lot of skeletons in the closet. So what are some specific examples of technical concessions or kind of compromises that you've had to make to try to get apps running in a container orchestration platform?
So from an anti-pattern point of view, from a concessions point of view, I think one of the big elephants in the room for us is just how we handle persistent storage for databases. And in our case, it's MongoDB. And then there's a big discussion around should you containerize MongoDB or not. And once you decide to do that, how do you manage that database in a containerized environment, and where do you put your storage, and how do you manage that storage? Do you replicate it? What are the tools that you have to do that? And we bent the rules a little bit, I think, in some cases, but we came out with a good strategy. In fact, my colleague Janelle will be talking about that at one of the sessions today. And but I'm not sure if I had to go back and do it again, I would containerize MongoDB, for instance.
Yep. So one of the anti-patterns that we followed is, everybody knows that containers are best when they're really small and lightweight. If you're transferring big image layers, you can run into lots of challenges. So we're testing Splunk, and the image that we have to test, we take Splunk as we ship it, we throw it into a container, and it's about a gigabyte container. So it's a very big anti-pattern that we follow. One of the ways that we've mitigated that is that we have a set of base layers, and we have our cluster, and whenever we release a new image or a new set of base layers, we automatically seed those across the cluster, so incrementally, like 10 servers at a time, so that we don't blow out our Docker registry. And that's enabled us to use really large image sizes without having huge load times or tearing down our network or our Docker registry.
That's a great point. Yeah, I mean, who has had issues with persistent storage and using EFS and burst credits and storage pools with connected disks across. I mean, there's so many challenges, right? And I think the biggest challenge that we've ran into, and it's great with this new feature that came out that was announced at the general session. I mean, it's, any platform, anywhere. And that's really the challenge that we've got is how do you take an app and move, especially a legacy app like what was demonstrated, how do you move that across clouds or to your edge, right? So, and then how do you take something that's not really stateless, right? That also creates challenges that you have to work around. And then some of the native challenges that we have in cloud as well, so.
We containerized Splunk too in the beginning, right about before you guys even had your containers out there. It was that was a lot of fun.
Yeah, so I would add that in this journey, if we are not making some concessions, it's troubling. So you can't make the perfect because, hey, these apps, some of them are written like so long back. Asking to be refactoring is a tall order there as well. And if you look at why you are doing this, if you have clear benefits defined, that, hey, we are doing Docker because we are going to go into a better security model with our VM or host images really small. You're not going to like install everything in the VMs anymore. Or you're saying my availability gets better. I can run the apps in my laptop, things like which you could never imagine, then making some concessions, I think, is not bad. Because then as you iterate through the journey, decomposition, microservices, all those things you want to do or make it more native can happen in parallel. But if you overanalyze and try to make the perfect from get-go, you are actually going to miss out on a ton of benefits, right? So that's what I would say.
It's such a great point, right? Cost benefits analysis, sizing up what you're trying to achieve, and then that really mitigates the risk later, right? So you're not trying to come up with functional and non-functional use cases and then designing around non-functional requirements being the core reason why you're deploying.
Yeah, good point. Don't let perfect be the enemy, right?
Yeah.
So in a lot of cases, we have companies that they require a solution that they depend on from another team. Monitoring, networking, storage, these are all good examples of this. Do you have an example of where you went to a team and there just wasn't a solution, so you had to do something yourself? And how often is this happening? Is it happening less as you go on? I guess if anybody wants to speak on that one.
Absolutely, we have a story around that.
Basically, every single portion, right?
Yeah, well, every single portion, but the one that really sticks out is one that I was intimately involved in as we were starting our journey, and that was what were we going to use to monitor this environment. So we had a couple of challenges. One, our legacy tools that we were using internally for monitoring our legacy environments didn't know anything about containers, so we couldn't use them. And the process to onboard new commercial tooling or proprietary tooling didn't meet our timelines at all. So we had to step outside of the box. We looked at a lot of open source solutions. We looked at some proprietary ones too that we really liked, but we settled on Prometheus and Grafana. And that was where we had to kind of take a step back and say, okay, nothing that we have works, but this works great. So we're going to go with that. And we're still using that solution today. Our monitoring team helped us when we started that journey, and we've since transitioned that entire infrastructure back to the monitoring team, and they own it now. And they're doing a great job deploying Prometheus all over the world for us and building Grafana dashboards and teaching our ops folks how to build Grafana dashboards. So it was a win for us.
Yeah, another example of the central team kind of taking ownership of some component and then handing it back after you've kind of learned the best practices about how to do that.
That's interesting too, because everybody talks about single pane of glass, right? And for us, we had 20 different monitoring systems, and there's so many open source solutions out there, Grafana and Prometheus, so forth, that you can use. And what we wanted to do is we wanted to drop an iPad off on the CIO's desk so he could look at everything. And so we gave that challenge to Splunk, and they were great. They came in, they integrated. Not only did we find use case with that, but we were able to find use case across the entire environment. So now you don't have just service delivery teams looking at failed pipelines. You have marketing looking at busted Tableau business intelligence reports along with deployment jobs. So I think you have to kind of take a step back and say, what are you communicating to the business? Because the business buys those graphs. They buy those charts. That's what tells them that you're successful.
Yeah, Matt, you bring up a good point. So I guess we'll go to the other guys. We'll start with you, Mike. So how exactly did you sell to your management, or what value were you delivering to them to try to get the investment in Docker in the first place?
So initially our use case was driven, as I mentioned earlier, by test. And in particular, we do a lot of performance testing at Splunk, and I was in charge of performance engineering for our solutions group at the time. And we found our customers are growing really rapidly, using it at really large scales. And we didn't have enough infrastructure, enough servers available to really run the large scale tests that we had. So the initial budget for us to build out a container orchestration infrastructure was actually funded by the need to do large-scale performance testing, where we had we got budget to buy hundreds of servers, and we realized that, well, now that we have these hundreds of servers, what are we going to do with them? How do we actually manage them? How do we set up testing? We want to do everything in an automated manner. So Docker just presented a really good way to have a very consistent result. Through the container image, you know what you're getting. You don't have the risk of these one-off servers that people can SSH into. You don't have the risk of build agents that can skew out of date with different packages. You have an image and it's the same, and you can guarantee it's the same across all your servers. So we really started treating all the servers that we got for performance testing as sheep, and that just made it a lot easier to manage that infrastructure. So we started out with I think 150 servers in the first batch. We grew in the course of maybe 9 months to 600, and we recently just finished an expansion to over 1,000 servers where we're running both on-prem in our data center, as well as we have new clusters that we've spun up inside of AWS. So largely it was funded initially by performance. Then we also realized, hey, now, since we're getting all this infrastructure, we're setting all this stuff up, we're building all this great tooling for testing, why only use it for performance? So we decided, hey, we could use this for our functional testing as well. And we started consolidating lots of different test frameworks that we had into a common framework that leverages the consistency that the container infrastructure provides. And then we recently finished the next stage of that, which is expanding out into all of our CI/CD pipelines. So we've been shutting down old servers and moving everything onto a single Jenkins server that orchestrates everything as containers. There's no agents, and now we're actually at the point where most of our pipelines and jobs that are running on a day-to-day basis are running as containers, and we're running over, 20 to 50,000 jobs every day on the infrastructure as well. So the use case expanded over time as we saw more and more value that we could get out of that.
I think our initial driver to sell to our management was cost reduction. Mm-hmm. That resonates really well with the management at an insurance company.
Money helps, yeah.
Money helps. And we were able to tell the story about how containerizing our applications and containerizing our infrastructure would allow us to oversubscribe systems that we already had or that we were purchasing and run more on less and reduce costs. I think we calculated somewhere between 65 and 75% cost reductions on infrastructure alone. And keep in mind, an insurance company in the US at any rate has to traditionally design for peak loads, and those happen during open enrollment. So we have to have all of this infrastructure sitting around doing nothing for most of the year, and with Docker that's not the case. We can now cloud burst if we want to, we can scale up, we can scale down, we can realize enormous infrastructure savings. So that was really, I think, the original business driver, the original selling point. Now, having said that, I talked about dashboards earlier. Those were cool too. They didn't sell the story, but I will say that when you're giving demonstrations to your executive management, having awesome dashboards in Grafana and Splunk goes 100 miles for you. We would see people's eyes light up. The operations folks in our leadership loved all of the beautiful dashboards that we presented, and we were able to kill nodes right in front of them and watch the dashboards blink from green to red. And we would see the workloads redistribute, and then the node would come back up, and it was a really compelling story that kind of tacked on to the whole business case and allowed them to buy in much more easily, much more visually.
So I'll add a couple of points there. We did not start with cost savings as a primary goal. And you may face that situation that you are under pressure to say that it is going to save cost because you're doing containers. For us, we did not start with the orchestration or a CAS model, which we are doing 2018. And so efficiency and cost savings is a big part of that. So when we started in 2016, it was more the fundamentals why containers became popular. So we said, he mentioned, okay, simple image works everywhere, stops that works here and doesn't work there, like common syndrome. But we looked into situations like it took us 1 year at PayPal to upgrade to a modern OS. And when you do that, you have to recompile every single tool in the whole world. We saw that why don't we use Docker and selectively upgrade the base images for the stacks we really want? For older application stacks, we brought them into a modern kernel where they didn't have to refactor any single line of code, and we saw like 15 to 20% performance improvements. In our stack, our deployment platforms were tightly coupled, knowing it's a Java app or a Node app. The scripts were very tightly coupled. We started opening up like, yo, you're a PHP or a Golang. We decoupled through the container primitives, those kind of things. So it was initially for us not cost, but now definitely it is in 2018. So, yeah.
Now, so one issue we see is, okay, we talked about selling, we talked about growing the team and building out the infrastructure. The milestone that a lot of companies hit after they've done all these phases and gone through and set the standards for containers is, okay, the architects go, we're going to go move on and go do some AI stuff or machine learning, and we're going to hand this over to the ops team. And then things fall apart again because the ops team hasn't been involved in the process or kind of, helped along the way. So what strategies have you guys used to keep the ops team in the entire process to make sure this doesn't happen?
So, as I noted before, we put together an innovation team, and it was cross-functional. We pulled people in from different parts of the organization. We had operational representation on that innovation team. In hindsight, we probably should have engaged them a little bit earlier than we did, and probably in slightly greater numbers than we did, because that operational handoff was a big deal for us. It was difficult when we got to it. We worked through it, and everything was great at the end of the day. But what we realized was, I think goes back to something I said before. Everything we were doing was brand new. We had a brand new type of application that was coming down the pipeline to operations. We had a brand new platform that application would be running on, and all of the shared infrastructure that application was using, like Redis and RabbitMQ and MongoDB and, Spring Boot and Node.js and all the typical, bits and bobs that wrap around that brand new shiny application were also brand new. So we had to figure out, how do we transition all of this to operations? And we started off with a training program. We put together comprehensive training for the platform and the shared services, and we presented that to our operations folks. What we found that was very interesting is that operations folks have day jobs that keep them exceptionally busy. So we did get a good cross-section of the ops folks engaged. A lot of them were overseas, and that made it a little bit more difficult. But we pulled that training program, that initial training program, together outside of our minimum viable product. Later on, today, my colleague Jeff Murr is putting together a much more comprehensive training program that starts off with some cornerstone work that Docker is providing as part of their Enterprise Champions program. And we're building custom content on top of that to help distribute the knowledge to not only our operations folks, but our engineering teams.
Now, Tim, you told me something about something pretty interesting that you guys did called war games.
Yeah.
What are war games?
So one of the coolest things that we did that I think helped our ops folks a lot was we went to war with them. And I love to say that. What we did was the innovation team became the chaos monkey. It was a manual chaos monkey. And we were...
How many SREs were hurt in this process? I'm sure everybody came out okay, right?
Everybody survived.
Okay, good.
But what we were able to do was inject failure into the environment, random failure over the course of a week. We set 1 week aside to do this, and we were able to measure our operations team's response times improve from Monday through Friday. And we started simple. So at random times during the day, we would tee up some failures. And they started off as maybe some container failures, or maybe a MongoDB container went down, or maybe a MongoDB filled up a volume or something. And then we escalated that till we'd shut a worker node down. And then we'd shut a master node down. And all of these would fire alerts into our operational intake system, and we would measure how long it took from failure to resolution. And we saw those resolution times collapse over the course of the week, and our ops teams got much greater value out of this than the training we gave, because it made them become hands-on. It made them touch everything and fix everything. So we would, ultimately, at the end of the day, we were shutting down entire fault domains. And like on Friday, we had like the big bang, where it was like a fireworks display at the end. Where,
you're a monster.
We broke everything. And it was completely an awesome experience for everybody. And we had fun with it. The ops folks had fun. We had fun. And it was a wonderful training exercise.
That's good to hear. What I really like about it is that you essentially put your SREs through the actual human process they would use to triage an issue. So you made them use the existing systems and things like that. It wasn't just about troubleshooting it, but you behaved as if it was an actual failure.
Exactly.
So we only have about 5 minutes left, and I want to try and get to one or two questions from the audience. So let's just quickly go down the line and tell me two things. One, what was the size of your team and number of people when you went into production with Docker? So how many people did it essentially take full time? And also, what's one thing you kind of wish you had done differently over the last 3 years from an organizational perspective?
The original team, the original Tiger team that we put together was 10 people, plus or minus 2, that then pollinated some work out to subject matter experts. So we had a kind of a hard boundary and then a fuzzy boundary outside of that. That team dissolved more or less once the work was complete, and then we formed a strategic container team. You could call it a container center of excellence team. And I don't know the exact number of that team, but I believe that it's under 8 today. And again, they still pollinate out to subject matter experts around the company, so there's some fuzzy boundaries there. I collaborate directly with that team, along with my colleague Jeff Murr.
So I think we had 4 to 6 engineers, but we had subject matter experts as well, so I would say 10 to 12 overall. We started. The second part, what we have done differently, I think things are going well. We phased out our journey. One thing I would just say, don't overpromise at any phase of your journey. Keep it very honest. Show your benefits. And actually that will help a lot. And because just a quick thing is today when you're reading about things, everything is in one single bucket. Service mesh to container orchestration to containers and things like that. So parse it out and plan it well for your kind of journey.
Great, yeah. I'd say anywhere between 8 to 10, same as these guys. It's the goal is to stay lean, not to have the same number that you had before, right? You're automated. Some other aspects that I would have liked to have changed. So ITIL, right? Continuous process is at the end of loop, where DevOps is continuous improvement, continuous development, right? So I think we would have embraced more IT for IT frameworks. I think the value stream mapping and building service catalogs is probably essential to giving the business the transparency that they're getting exactly what they asked for, right?
So we started out probably with a team of about 10 as well. It's probably about the same core. The core team's about the same size as today as it was then. People have changed, and there's also a number of people that knowledge has transferred to. So there's probably maybe 20 or 30 people in all that touch the infrastructure and code at any point. One of the things I wish I would have done differently was focusing more on ops sooner. Inside of our area, part of our charter is managing the infrastructure for our teams, for our engineering teams. So rather than handing over ops to another team, it's our responsibility to manage this infrastructure that we built. I think we made the mistake of not putting dedicated people who are fully dedicated to running that infrastructure and understanding it and watching it. It took us way too long to start establishing that team, and I think we suffered a little bit for it.
Thanks a lot. So we probably have time for one question. I think there's a mic, actually. Oh, she's got it. And he's closest to the mic, so I think he wins.
Thank you. Meg Dude from PayPal had mentioned that he had started out with some virtualized containers. I'm just wondering with the other companies, do you have that phenomenon as well, that basically embedded inside of VM, and whether there's a difference between on-prem and your cloud for that use case?
We'll take that one.
I think you wanted to hear from others.
Yeah.
Okay, sorry, I caught half that question. Sorry.
No, the use case of running containers as part of a virtual machine, is that something that McDude had said he started out that way. Is that something your other companies are doing as well? And if so, are you doing them both for on-prem and for cloud use cases?
That's a great question. Yeah. So right, IaaS is expensive in cloud, right? So to put IaaS on top of containers, where's your return, right? I would say what we found is by leveraging like Docker on top, what we found is we end up with security and compliance issues that cost us more, where they want stronger mitigating controls, so we have to pay for high trust and things like that. So that's where we found that leveraging that kind of single platform, single cloud model. But yeah, we extend, we use Edge SD-WAN technologies to talk back and forth between clouds and to talk between clouds, so like the Googles and the Azures and those kinds of things. And then we use Jenkins functions to deploy across most of those, and Splunk to monitor the whole thing. But that's how we approach that problem.
One of the things that we did is we started out on-prem inside of a data center running everything on bare metal, and we migrated over time to doing more and more inside of VMs in AWS. And one of the I've seen a lot of advantages to running containers on VMs, just because managing bare metal servers is hard and not a very fun thing to have to do. And it's so much easier when you can just have an auto-scaling group and terminate servers when they go wonky. So if I were to do it again, I would, and I had the option, I would not have any on-prem servers and not do any bare metal.
Good. So that is all the time we have, but our panelists will be down here if you want to ask more questions. So these guys have been on the cutting edge for a long time, and sometimes it actually cuts. And so give them a round of applause for everything that they've learned. Thanks so much for coming up here.
Thank you, Mark.
Thank you.